Assalamu alaikum, my dear student. Today we will talk about the introduction to differential equation. So first I will define you what is differential equation. An equation which involves differential coefficient is known as differential equation. I give you example, student. For example, dy over dx, which is equals to 1 plus x square upon 1 plus y square, dy over dx, d2y over dx square equals to 2 into dy over dx minus 8y. Similarly, cos of x into d2y upon dx square plus sine of x dy upon dx whole square plus 8y, which is equals to 10x. So these are the differential coefficient dy over dx, d2y over dx square, dy upon dx, d2y over dx square. So it means this is called differential equation. So an equation which involves differential coefficient, it is known as differential equation. So there are some examples about differential equation. After the addition, there are two types of differential equation. So types of differential equation is, there are two types of differential equation. There are two types of differential equation. The first one is ordinary differential equation. The other one is partial differential equation. DE represent a resistant differential equation in short form, the partial differential equation. So first we talk about what is ordinary differential equation. So now write a definition about ordinary differential equation with examples, and I give you examples about the ordinary differential equation. A differential equation involving derivatives with respect to a single independent variable is known as ODE. So ODE represent here ordinary differential equation. It means dy upon dx, a single independent variable. It means a differential equation involving derivatives with respect to a single independent variable. This is called independent variable. This is dependent variable. So dy over dx, which is equals to x plus y square, dy over dx, which is equals to sine of x minus x, or dy over dx, which is equals to y plus x over y minus x. So these are the examples about ordinary differential equation. Now we will continue, student, and we will talk about partial differential equation. A differential equation involving partial derivatives, involving partial derivatives involving partial derivatives with respect to more than one, with respect to more than one independent variable. Is known as partial differential equation. In short form, if we write here is PDE. PDE represent here partial differential equation. Now I give you example about the partial differential equation. Examples: x into dava u upon dava x plus y dava u upon dava y, which is equals to 2 times of u. Now the other example, it is dava 2z over dava x into dava 2z upon dava x into dava y, which is equals to dava z over dava y. Similarly, dava 2z upon dava x into dava x, which is equals to dava z upon dava y. So these are the examples about, student, because with respect to a differential equation, it means involving partial derivatives. Dava upon dava y represent here the partial derivatives with respect to more than one independent variable. So these are the independent variable x, x one time or more than one times. So that's why we call it partial derivative with respect to x. In another way, if we write here f of xx, which is equals to f of xy, f of xy, f of yx, and f of triple times of x. So in another way, we call it, these are also called the partial differential equation. Represented by in this way. So student, we will continue the topic, and we talk about, when we talk about the differential equation, it is very important for you don't know about the order and degree. So first we call about the order. What is order? The highest differential, the highest differential coefficient, the highest differential coefficient present, the highest differential coefficient present in the differential equation, in the differential equation is known as order. For example, If we consider student d2y over dx square is equals to 2 times into dy over dx plus 8y, find the order. It means the highest order, the highest differential coefficient, it means 2 times derivative. If we take present in the differential equation, this is called order. Order is 2. Similarly, the other example it is 1 plus dy upon dx whole square or overall whole cube, which is equals to d2y over dx square and whole square. So it means the highest order, this is the order of the differential equation, it is 1, its whole power 2, not an higher order. d2y over dx square, it is an higher order. So this is called the order of differential equation is called 2. The order of the given differential equation, it is 2. Now the third example, cos x into d2y over dx square plus sine of x into dy upon dx whole square plus 8y equals to 10x. Now find the order. So highest, the order of the differential equation, it is 1. This is not highest. So now the order of the differential equation, the highest differential coefficient in present in the whole equation, whole differential equation. So we call it the order, it is 2. Now the other examples about order and degree. So for example, if d cube y upon dx cube whole power 2 upon 3 is equals to dy upon dx plus 2. So this is the order of the highest order of the highest derivative in the present in the differential equation, it is 3. So the order, it is 3. For example, if the differential equation, it is in a square root, so first we will remove the square root. So dy over dx whole cube, cubic root, for example, it is plus 5. Now what is the order? If we consider here the highest order, the highest derivative, it is 2, it is 1. So the order of this differential equation, it is called 2. And the last example about the order, dy over dx is equals to 3x plus 5. This is called the order. So highest differential coefficient present in the differential equation, it is known as order. So order of the given differential equation, it is 1. So after that, we will talk about the degree. How can we find the degree of the differential equation? So what is degree? Right, a definition about the degree: exponent of the highest differential coefficient, exponent of the highest differential coefficient, highest differential coefficient exponent of the highest differential coefficient when the equation is a polynomial in all differential equation. In all differential equation. So this is called degree about the differential equation. So highest differential coefficient when the equation is in a polynomial in all differential equation. For example, do you know about the polynomial function a naught x raised to the power n plus a1 into x raised to the power n minus 1 and plus up to so on an x naught. The last one, we consider x will be removed, so we write only an. So it means this is called polynomial function. So exponent of the highest differential coefficient when the equation is a polynomial in all differential equation. For example, when we talk about if you find the order of the differential equation, see, this is called the order of the differential equation, and the exponent of order of the differential equation, it is 1. So the degree of first example, it is 1. We will find the degree. So in the first part, degree is 1. Now the second example, when we consider here, student, this is highest order, it means highest differential coefficient, and highest differential coefficient of the exponent, it means power. This is called degree. The second part, it is degree 2. Now second one, the third example, if we consider here, the highest order, it is the highest differential coefficient of the differential equation, it is 2, but the exponent of the highest differential coefficient, it is 1. So the degree, it is 1. So the second part, degree is 2 and degree is 1. Now fourth example, when we consider here about the degree, it has a fractional part. Fractional part, if it means if we multiplying by, for example, it is 3 taking exponent on both sides. So it means 3 divided by 3. So the order, highest order of the differential equation, it is 3, but the degree is 2. For the fourth example. Now number fifth example is when we consider a highest order of the differential equation, it is d2y upon dx square whole power 1 over 2. It is in a fractional. So we will taking exponent 2 on both sides. So dy over dx plus 5 whole power 1 over 3. So it means we multiplying by 2. It means taking exponent on both sides. So it means they should be cancel each other. So the answer, it is the highest order, the highest differential coefficient, it is 2. That means it is order, and the exponent of the highest order, it is 1. So the degree, it is 1. And when we consider it as highest order, and it is called the exponent of the highest order, it is degree. So both are degree 1. So we easily determine the degree and the order of any differential equation. For example, if you have d2y over dx square equals to sine times of y upon x. When any transcendental function multiplying by the polynomial function, so it means it has no degree, and the order it is 2, but the degree is no. Degree is nil in another way. Because it is not a polynomial function, it is a transcendental function. Any transcendental function like as if sine, cos, tan, cot, cosec, sine inverse, cos inverse, tan inverse, cot inverse, cosec inverse, log, ln, exponential function, for example, exponential function. So these are called transcendental function. So transcendental function if present in the given differential equation and multiplying by the variable y or x, so it means it has no degree. After that, student, we will talk about the how can we form it, formation of differential equation. How can we form the differential equation? So formation of differential equation. It can be formed, student, it can be formed by differentiating, it can be formed by differentiating the ordinary differential equation, the ordinary equation and eliminating the arbitrary constant and eliminating the arbitrary constant and eliminating the arbitrary constant. So that's why we formed a differential equation. Now write a question about the how can we form the differential equation, student? So the first question about form the differential equation by eliminating arbitrary constant, of the following. For example, the first equation, general equation, ordinary equation you have given, y is equals to a of x plus a square, y is equals to a cos of x plus b times of sine x. I give you two examples about how can we formulate the differential equation. So these are called, a and b are called arbitrary constant. So it means, student, if you take y is equals to a times of x plus a square, differentiate with respect to x, we get means dy over dx, which is equals to a, the constant, the value of constant is 0, derivative of variable with respect to x, it is a. It means x, it is 1, a into 1, it is a. So what is dy over dx? Dy over dx, which is equals to a. So we put here, student, and write the name of the equation, for example, a, or if you write here 1, because they are similar, that's why we write here. So put dy over dx, which is equals to a in equation 1. We get. So it means y is equals to a of x, means x times of dy over dx, because they are equal. So we put here dy over dx whole square. So this is called differential equation. So we can form easily, student, when if applying the derivative. If you take the derivative with respect to x of any function, then you will find easily. Now the second example, when we consider here, now the second example we consider after that. So y is equals to, for example, second example, y is equals to a cos x plus b sin x. Differentiate with respect to x. Students, dy over dx, which is equals to minus a sin x, because the derivative of cos is minus sin, plus b as it is, because it is multiplying together. The derivative of sin x, it is cos x. It has no result, so we will again the derivative with respect to y, with respect to x. So it means dy into dx, which is equals to d2y over dx. It means if you write in this form, dy over dx, again derivative of the given function with respect to x. Both way are similar. So it means d2y over dx square when we multiplying together. So it means the derivative of sine is cos x, and the derivative of cos x, it is minus sin x. It has no result till the second derivative. Now again we take the third times derivative. It means d cube of y over dx cube. It means third time derivative. If we take the given function, the derivative of cos x, it is minus sin x. Because if we take, student, if we taking common from this, so both equations are similar, so we will stop here. So d2y over dx square minus common if we take, so a cos x plus b sin x, because both are similar, so it means we will put here minus y. So the answer it is, if you write d2y over dx square, if we y shift on the left hand side, student, so d2y over dx square plus y equals to 0. This is called differential equation. So these are the examples about differential equation, student. After that, we will talk about the difference between, student, linear and non-linear differential equation. So we will talk about the linear and non-linear differential equation. If the differential equation, when we consider the differential equation is called linear and otherwise it is non-linear. So it has some rules. We write here, a differential equation is said to be linear, is said to be linear if the first, and it has some two parts, degree of differential equation, degree of differential coefficient, degree of differential coefficient in each term should be 1. In each term should be 1. Should be 1. Now the second part of the first rule, it is degree of dependent variable, degree of dependent variable degree of dependent variable in each term should be 1. This is called first rule. Now the second rule, there should not be any term containing any term containing any term containing product. Further, it has two parts, student. It means no one the product, any term containing the product. For example, xy multiplying by the differential dy into dx. So it has further two parts, the differential coefficient, the differential coefficient, the differential coefficient with dependent variable, with dependent variable. Now the second one is differential coefficient with each other. When the differential coefficient with each other, now the third rule is neither differential coefficient, neither differential coefficient neither differential coefficient non-dependent variable, non-dependent variable, it means independent variable in another way, and or 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 in transcendental. These non-dependent variable, it means transcendental, means no transcendental function variables are present in the differential equation, differential coefficients. If any more, if any one of the above condition, if any of the above condition, if any of the above condition is violated, then equation is said to be non-linear. Then the equation is said to be non-linear. So these are the rules, student. We follow it. I give you example about and identify which differential equation is called linear and which differential equation is non-linear. So write an application. I give you some examples. With the help of example, we identify easily linear or non-linear. So dy over dx plus root y is equals to sine of x. It means because it is in the square root, because the dependent variable it is in the square root, a differential equation, degree of differential equation in each term should be 1. So it has no degree. Degree of differential equation it is 1, but the other one is it is in the square root. So we call it is non-linear. Because y is the dependent variable. It is in the square root. It means it is a fractional part. The variable y it is in fractional power. So that's why we call it is non-linear. Now second example, d cube y over dx cube plus 3 times d2y over dx square minus 5 sin x, which is equals to 0. When we consider student, degree of differential equation in each term should be 1, degree of dependent variable in each term should be 1. So it means degree of differential equation it should be 1. So it means this is called linear differential equation. So there are so many examples about linear and non-linear. I give you some examples other. For example, student, d cube cube y over dx cube minus sine of x into d2y over dx square minus cos of x, which is equals to 6. So student, it has order, it is 3, but degree is 1. So the first, according to first rule, the degree of differential coefficient in each term should be 1, but the degree of dependent variable in each term should be 1. And the next term, there should not any term containing product differential coefficient with dependent variable or non-dependent variable. So here we applying this condition with transcendental function, neither differential coefficient non-dependent variable, or it means it is transcendental function. So this is called transcendental function if it is multiplying by the differential coefficient. So that's why it is called non-linear differential equation. So there are some examples about linear and non-linear. You can identify easily according to rule. Both are transcendental function, right? So if it is here multiplying this, so we will not consider this one. So continue the topic, student, and when I give you example about the application of differential equation, how can we apply? Where we applying the differential equation? There are so many examples in our real life. So application of differential equation, I give you some examples about. There are so many applications in our real life of differential equation. For example, if we find the rate of change, this is called differential equation. With the help of differential equation, we will find a spread of disease. With the help of differential equation, we will find it. Weather and climate prediction. Weather and climate prediction with the help of differential equation. Prediction. Chemical reaction with the help of differential equation. Population growth with the help of differential equation, we will find easily population growth. Differential equation model. With the help of differential equation model, we will find the population growth. Brain function, water pollution. With the help of differential equation, we will find brain function. With the help of differential equation, we will find easily the brain function, planetary motion. So these are the examples of the differential equation in real life, and so on. There are so many examples about the application of differential equation. After that, student, what is the solution of differential equation? An equation containing dependent variable y and independent variable x and free from derivative which satisfies the differential equation. This is known as solution of differential equation. This is known as solution of differential equation. I give you example, student. For example, if the solution of differential equation in this form, sine of xy, which is equals to 1 upon 2 times of x square plus c. C is the constant of integration. Y is sine y plus x square log of x, which is equals to c. This is called solution of differential equation. And y minus tan of x plus y upon 2, which is equals to c. So these are the solution of differential equation. And after that, we will discuss today about the standard method of there are some standard methods of solving first order first degree, of solving first order and first degree differential equation. So there are four substandard methods. Four standard methods. Number one is variable separable method. Today we will discuss about the variable separable method, and the remaining in the next lecture, inshallah. Now the next one, it is homogeneous equations. Number third, linear equations. Linear equations. Number four, exact differential equation. So these are the four standard methods we will discuss in when we talk about the first order first degree equations. So first we will consider today, student, variable separable method. Variable separable method. It is easy method, student. Variable separable method. It means if a differential equation can be written as f of y into dy, f of y into dy, which is equals to phi of x into dx. It means a function depend on y variable multiplied by dy, and the function phi depend x variable multiplied by dx always. So it means y on the left hand side and x on the right hand side. Each term of x right on the right hand side, and it is y on the left hand side. That is, if we write here, that is y is on left side and x is on right hand side, is on right side, in another way, short form. So it has working rule, working step. It means there are two working steps to find the differential equation, solution of differential equation. The first one is separate the variable, student, like this form. Separate the variables means f of y into dy, which is equals to phi of x into dx. Then in the next step, after simplifying, integrate both sides. Integrate both sides. Then we are applying the integral signal, integral sign, and in the next step, we will integrate with respect to y and with respect to x and find the solution of the differential equation. So, student, we consider an application about the variable separable method. Solve dy over dx, which is equals to x times x into log of x, 2 times of log of x plus 1 whole upon Sin y plus y into cos y. When we consider the differential equation, student, all in the numerator, the variable x present here, and in the denominator, all variables represent here y variable. So it means when we shift here y into this function, it is divided by the term. So when we shift on the left hand side, it means it should be multiplying y cos y. So sin y cos y. If you write the first, you first write the differential equation, then we will start now. So student, first we write the differential equation, then we will start, because it is a question. When we find the solution, now the first step, it is variable separable method, means when dy present, so it means we shift this term on the left hand side and dx shift on the right hand side. So it means this is called variable separable method. So according to variable separate the variable, if we write here separate the variable, separate the variables, we get, so it means sin of y plus y cos y into dy, which is equals to x 2 times of log of x plus 1 into dx. Taking integral sign on both sides, but not we integrate, only we applying the integral sign. So it means taking integral sign on both sides, integral sign on both sides. You know very well, student. First we separate the variables, then we integrate sin of y into dy, integral sign plus y into cos y into dy, which is equals to similarly x times log of x multiplied by 1, it means x into dx. If we consider, student, there are two variables, it means u into v in integral. So this method is called integrate by parts. Integrate by parts. So according to integrate by parts, we will find the integral of this term and this term. Integrate by parts. Integrate by parts. So integrate by parts, we will consider here and find the integral of sin y, it is minus cos y. So integrate by parts, it means, student, when u is constant, the derivative of cos, it is sin y. The integral of cos y, it is sin y minus sin. The derivative of u is 1 and the integral of the given function, it is sin y. So we write here sin y into dy on the left hand side. So here 2 times of x as it is, because log of x we consider here, it has no integral. That means we will consider u and x is called v. You select which one is u and which one is v, because log of x, it has no integral. That means we will consider u and x is v. So we put here and u and v. So what does it mean? It means 2 times of constant. 2 is a constant term. So the derivative of x is constant. It means u is constant. The log of x is constant. And the integral of x is x square over 2. The integral of x into dx, it is x square upon 2 minus sine. The derivative of log x, it is 1 over x. The derivative of log x, it is 1 over x, multiplying by the integral, it is x square over 2 into dx. So this is called the integral plus the integral of x dx, it is x square over 2 plus c. C is a constant of integration. Now in the next step, student, further the step, it is minus cos y plus y sin y. The integral of sin y, it is plus cos y. So sin y integral, it is minus, so minus minus plus cos y. The integral of sin y is minus cos y minus minus plus cos y, which is equals to 2 times of log of x, or if you write two divided by 2. So it means in the next step we will continue the 2 times of x square upon 2. If we write first, so 2 divided by 2 minus sine x divided by x and 1 upon 2 multiplied by 2. So 2 into 1 upon 2, because 2 multiplying for the whole term. So it means remaining x into dx, it is x square upon 2. So 2 divided by 2 plus c. So the answer, it is minus cos y and plus cos y, they are cancel each other. They cancel each other. Y sin y is equals to x square log of x minus x square upon 2 plus c. I have a mistake, plus x square, I miss this value. So I have a mistake, student. So this is called minus x square, but I have a mistake. The last term, it should be plus x square upon 2 plus c. So we miss this value. So it means minus x square upon 2 plus x square upon 2, because it is minus, so they cancel each other. So the answer, it is. Now we will consider the next application about the variable separable method, question number 2. So now write an application, solve the differential equation, solve the differential equation x4 into dy over dx plus x cube y, which is equals to minus sec of xy. So if we write here is x4 into dy over dx, which is plus x cube y equals to minus sec of xy. If we take common in both terms, it is x cube into x into dy over dx plus y equals to minus sec of xy. So after form this equation, we will put here, okay, let b is equals to xy. So then dy over dx, dv over dx, now dv over dx, because when we find the derivative, which is equals to x into dy over dx plus y. When we find the derivative, u into v, this will be dv over dx. So student, when we put here, because they are similar, so we put here. So if we write the name equation number 1, so 1 implies that x cube into dv over dx, which is equals to minus sec times of b, because b is equals to xy. So we replace this value with the term b. So in the next step, separate the variable, separate the variables. So it means sec v, when we shift on the left hand side, means it is in divided form, and minus the x cube upon dx, it will be converted into dx upon x cube. This in the next step, if we shift this number x to the power minus 3 into dx and applying the sign integral 1 upon sec y, which is equals to cos v, and taking the integral sign on integrate, we get the integral of cos is sin v equals to minus x raised to the power minus 3 plus 1. So it means minus 2 upon minus 2 plus c is a constant of integration, and minus minus plus. So 1 upon 2 x square plus c. If we shift this value in the denominator, so the sin v is equals to 1 upon, put back v, put back v. What is v? V is equals to xy. So therefore, sin of xy equals to 1 upon 2 times of x square plus c. So this is called the solution of the differential equation by the variable separable method. So I have completed my lecture, student. I hope you will learn about, because our lecture depend on the introduction to differential equation, and we have discussed the order and degree, formation of differential equation, and variable separable method. So thank you very much. Take care. God bless you. Allah Hafiz.